Hello, my name is Bruno, and in this video, I will demonstrate how to predict mortality for medical notes using big data technologies. First, a bit about the background of this topic. When patients are admitted into hospitals, a number of routine checks are performed and everything is documented. Medical notes are also written at the time of admission, during treatment, and at the time of discharge. This generates a lot of data for each patient to the point where doctors simply don't have the time to go through all that data. This is not always ideal because hospitals should be equipped to quickly identify patients at risk of dying to provide timely assistance and prioritize care. So if a system could automatically parse all these notes and guide doctors, that could be a game changer in terms of the delivery of care to patients who need it most. So in this project, I address this issue by combining different big data technologies to automatically parse medical notes and predict whether a patient died during hospitalization. This is accomplished in 3 steps. The first step is to convert the medical notes into numeric representation. Pyspark was used to read the notes from disk, remove punctuation, remove numbers, English stop words, and to tokenize the text into words. Words were then counted using the count vectorizer in pyspark, giving us a bag of words model for each note. In other words, a word count for each note as shown here on the right. So for example, patient showed up 24 times in a particular note. And here at the bottom of the slide, the top 10 words are shown, with the most common referring to the amount of medication administered to the patient, specifically milligrams and tablets. The next step is to retrieve and binarize the discharge status of the patient to either alive or dead. So this data came from the admission record data, and there's a different number of discharge locations, and one in particular is of interest here. It's called dead expired, and that one got converted to a 1, and everything else got converted to a 0, meaning that the patient left the hospital alive. And then as shown on the right, there's an imbalance in terms of the number of patients that left alive versus the number of patients that died during hospitalization. The last step in this 3-step approach is to train a model to predict mortality. So we first combine the numeric representations of the medical notes with the discharge status of the patient being a binary status, either 0 or 1. We construct and train a deep neural network using TensorFlow. In this case, the network consisted of a few layers that I will show when I get to showing the Jupyter notebook. And then we use that network to essentially predict whether the patient died during hospitalization or not. The model was trained for a total of 25 epochs, and here the accuracy and the loss of the model in terms of the number of epochs is plotted. So starting with the graph on the left with the accuracy, we see that as we increase the number of epochs, both training and validation accuracy go up, although around 10 to 15 epochs, the accuracy plateaus and doesn't really change afterwards. So in this case, we could have added an early stopping criteria to stop training around 15 epochs. However, if we look at the loss diagram on the right, we can see that both training and validation loss keep going down as we increase the number of epochs up to 25. The model reached a final test accuracy of 0.9 on unseen data. Performance was also assessed by looking at the area under the ROC curve for both the training set and the test set, and in both cases performance was above 0.9, indicating very strong performance. So here's an overview of the software and hardware that was used to complete this project. In terms of software, Python 3.8 was used, specifically the distribution that comes with Anaconda. PySpark 3.0 was also used for most of this project, in particular for parsing the medical notes and for retrieving information from the admission records. TensorFlow was used to construct the neural network. NumPy was used for numeric computation, and Matplotlib was used to plot the data and to plot the results of the model that was trained using TensorFlow. In terms of hardware, I ran everything on my laptop, which is a MacBook Pro from roughly 2 years ago with a lot of memory, 64 gigabytes of RAM. Before going over a demo of this project, let's first talk a little bit about future directions. So as mentioned, a neural network was trained to predict mortality for medical notes, but it might be interesting to look at other models to see how performance compares. We also used the count vectorizer to convert medical notes into numeric representations, and this is essentially just a simple word counts for each of the medical note, and it would be interesting to look at other natural language processing techniques that are better able to capture grammar or word order or semantics in order to see if that would improve performance. Another potential limitation here is that all the data that was used in this project was collected from a single institution, specifically the Beth Israel Medical Center in Boston. And there may be standards in terms of how medical notes are written at that particular institution that would allow this model to work, that might cause this model not to perform as well in other institutions. And so there would be some work to be done on that in order to make sure that the model would generalize well across institutions. Another important thing that this model could be used for would be not only to predict mortality at the time of discharge, but also ahead of time. So if you could predict that a patient was going to die from medical notes that were written in their previous visit at the hospital, that would be a very useful model. So let's see how this works. So the code demo that is provided as part of this project consists of all the files that are listed here. So all the code that you need to run this project is contained in the Jupyter notebook located here. A small sample of the dataset is provided, specifically some data about admissions and note events. There's a README file indicating how you can set up your local environment and everything you need in order to run this Jupyter notebook. There's a requirement file listing the Python packages that you're going to need in your environment in order to run this notebook. And finally, there's a setup script that essentially allows you to create an Anaconda Python virtual environment, install all of the requirements that you're going to need to run this project, and then it automatically launches pyspark. So before running the setup script, you need to first install Anaconda on your machine. Specifically, Anaconda with Python 3.8 was used for this project, and you also need to install pyspark. Once you do that, you can simply run the setup script. It will create the Conda environment called Mortality, install all the packages that you need, and automatically launch pyspark. From there, you can select the notebook for this project, open it, and then click Cell, Run All in order to run all of the cells contained in this notebook. The notebook is divided into 5 parts. In the first part, we're going to use pyspark and natural language processing techniques to essentially convert the medical notes into numeric representations. In the second part, we're going to retrieve the data about the patient status. In the third part, we're going to be combining those two data sets together. In the fourth part, we're going to use that data to train a neural network. And then finally, in part 5, we're going to evaluate the performance of that model on the test data, which wasn't seen by the network during training or validation. So first, we import all the packages that we need. In this first part, we load all the notes using pyspark. Shown here, there is 11 different columns, and the one that we're interested in is called text, which really contains the textual data for the medical notes. Everything else is metadata about the hospital admissions or metadata relating to that note. And here we see an example of a medical note, and you can see that there's a lot of characters that we might want to remove, and also dates and unnecessary spaces or new lines. So the first thing that we do is we clean that up. So moving down here, we can see here another example of a note. Here, just checking to make sure that there are no nan or null values in any of the columns. And if in this case there are none, but if there were any, we would remove them. Here, just counting the number of characters in some of the medical notes just to get an idea of how long they are. And here's one of the functions that we're using to clean the notes. So we're removing punctuation, removing the numbers, and also replacing basically removing the new lines and unnecessary space characters. Here we have an example of a note that's been cleaned up in terms of removing all the new lines and all the punctuation and all that. Then we tokenize that into a list of words. Once we have that list of words, we can clean it by removing the English stop words. And now you can see that the list of words that we're dealing with is starting to look a lot cleaner. And finally, what we do is we count the occurrence of each of these words across each node. And this is called a bag of word models. And the way that we're constructing this model is by using pyspark count vectorizer. So taking as input the list of words and converting that into a list of word counts as shown here. So this is a sparse vector in pyspark. Next, what we do is we can plot the most common words in either a single node or across a very large number of nodes, as shown here. So here we're plotting the most common words across the first 1,000 nodes. In the second part, we retrieve the status of the patient at the time of discharge. And so this is done by looking at the column called discharge location, and either the patient is dead or was discharged successfully from the hospital to a different institutions. But all of these refer to the patient being alive when they left the hospital. There's roughly 10% of the data that consists of patients that died during hospitalization. So we're going to need to balance that a little bit later when we train the model. And this is shown here. Finally, in part 3, we merge those two data sets that we were just discussing. So the medical notes, the numeric representations of medical notes, and the admissions data. Finally, in part 4, we start balancing the data set to make sure that we have an equal number of patients in each category in order not to bias the model. Here, we build the neural network model. The architecture is shown here, so just a few layers and regularizers and dropout layers were added to help the model better generalize. Here we can train the model for 25 epochs. And here we can plot the history over time. It doesn't look as good as the ones that I was showing in the slides, just simply because this is a smaller data set that we're using for demonstration purposes. And finally, in the last part, part 5, we compute different performance metrics for the model, including the false positive rate, true positive rate, and we use that to generate a ROC curve to give us a better idea of the performance of the model. And even on this small data set, you can see that the area under the ROC curve is very close to 1 for both the train and the test set, indicating that the model is performing very well. So this is how you can predict mortality by simply parsing the content of medical notes using big data technologies, including Spark natural language processing techniques and deep learning. Thank you for watching.